It is pressed. It is working.
It's working. It's confirmed correctly. Okay.
Yes.
All right. Here we go.
Yes.
Astronomy Cast, episode 573, Exoplanet Atmospheres. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, is Dr. Pamela, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
I'm doing great. Actually, normally we talk about how wonderful the weather is, but actually here the weather's gotten really nasty again. It's gotten cold and rainy, and it's been a pretty mediocre springtime. So, and we're stuck indoors. So, although amazingly, they've decided that the virus is pretty much wiped out on Vancouver Island. So at this point now, no cases in 2 weeks, nobody in the hospital. We have no issue.
So clearly what you need is absolutely no more travel, no guests, no visitors, isolate the island, lock
shutting
down
off
the
island.
borders.
Yeah, no one else can come to our island until that vaccine gets created. It was like a mini New Zealand.
And so we're not so lucky here. We're dealing with the fact that in the United States, the Memorial Day holiday weekend led to lots of people getting together, and we're having a resurgence nationwide. And here in the small town I live in, we've had 7 new cases diagnosed in the past week. But to get tested, you have to be so sick they're going to hospitalize.
Right. So definitely remain
of the people they've
inside.
tested, 10% have. Oh yeah. People in my life will not let me leave my house. Well, or leave my yard, as the case may be.
And I think it's important for us to just mention, I mean, as a Canadian, I'm watching what's going on in your country right now with shock and horror, and yet this is clearly a long time coming. And I just really hope that this time around, the people in power listen to the desires of the individuals who have had various levels of oppression. It has gone on for too long. It's ridiculous to see this happen again and again. And it's great to see both the amount of protests and just the showing of support that's going on, and to see, I hope, people taking this seriously and enacting significant change. It's
to put things bluntly, Black Lives Matter, and for too long that they have been considered disposable by the police here in the United States, where we see white serial killers, people who shoot up schools, getting carried away in handcuffs and given hamburgers, and white supremacists allowed to fill our Capitol buildings while wearing submachine guns with nothing happening. We have watched as children get killed playing in parks with water guns. We have seen a teenager walking home with Twizzlers get killed for no reason.
And
Black Lives Matter.
And this has been going on. It was just with the most recent event, it was just such a stark, obvious, well-documented example of a man being killed by police in real time, and you got to see it. So
1 in 1,000 Black men and boys in this country can expect to be killed by the police.
So you have our support in Canada, everyone who's protesting, and we will continue, I think, to keep this in the forefront of all of our minds as we move forward. That said, let's get on with the astronomy. So not only have astronomers discovered thousands of exoplanets, but they're even starting to study the atmospheres of worlds thousands of light years away. What can we learn about these other worlds and maybe even signs of life? So before we go on, apparently the Twitch stream isn't working.
Oh, good Lord. All of that, and okay, now it's definitely working. It crashed at some point, and now it's streaming.
Okay.
I hate everything.
All right. So Pamela, at this point now,
to edit that.
Yeah, no, of course. Yeah. So at this point now, of course, we know of more than 4,000 exoplanets. I've lost count. It's too many to count. It's in the thousands, which is such great news. But all we know about the vast majority of these planets is it exists. It goes around the planet, around the star every X amount of days, weeks, months. It might be this size, it might be that size, and it might have more or less mass than the Earth.
Right.
But we don't know much, and that's kind of boring. What we really want to know is there atmosphere? Is there liquid water? Are they in the habitable zone? Does it look like the kind of world that we could find life on? Finding and actually examining the atmospheres is next level. So what does it take for some kind of telescope to be able to examine the atmosphere of an exoplanet?
What it takes, quite simply, is catching a planet in the process of passing in front of the star it orbits and being able to get sufficiently high resolution spectra, both with the planet in front of the star and not in front of the star, that we can see what the planet's atmosphere is when we subtract the star's light from the star plus planet's light.
Right, so let's talk about that idea of the spectra of the star and the spectra of the planet. So what are you talking about there?
So anything that is giving off light is giving it off in some portion of a rainbow. This means that if we recreate the pink floor, light through a prism, we see it spread out to a rainbow. Now, it turns out different atoms will absorb light and emit light in very specific colors that are determined through quantum mechanics and the exact temperature and energy configuration of that atom.
Right.
So when we look at a spectrum and we see superimposed on this rainbow dark lines and bright lines, absorption and emission lines, we can say this rainbow captured the absorption and emission of light from this specific set of atoms. With our sun, this allows us to get at the composition of its atmosphere. And with our own atmosphere, we see lines that are getting absorbed out of the sunlight by water vapor in the atmosphere. Water vapor is one of the most annoying things in our atmosphere that plagues spectroscopists.
Right.
So we can measure our own atmosphere with our telescopes.
Right. So you take the light from anything, a star, a galaxy, a planet, whatever you want, you break that light, Pink Floyd style, into a rainbow, and you then you blow that rainbow up so that it's really big, and you will see dark lines and bright lines in that rainbow. And from that will tell you the presence of various chemicals. You'll say, oh, there's oxygen there. Oh, there's water there. Oh, there's uranium there, right? each element, each atom will provide a very specific signature. Now, you don't know how much there is. You just know that it exists, right?
Well, you can actually start to get at how much based on how much absorption or emission is going on. Each atom is contributing its own number of photons, but it can only do so much by itself. It's through atom upon atom upon atom working together to absorb that light that we're able to see the bright and dark bands that we see.
Right.
Now, if you only have the smallest amount of oxygen in a planet's atmosphere, we may never see absorption lines from that because there's just not enough atoms to do the absorption. But if a planet that has an atmosphere rich in oxygen passes in front of its star, we will see that as deeper lines in the spectrum. So we can actually start to get at ratios of how much of one atom or molecule is present versus another atom or molecule.
And so then let's talk about how this relates to studying the atmosphere of a planet. So you're taking this rainbow, you're watching the star, you're getting one rainbow, and then the planet passes in front of the star, and then you get a second rainbow.
Yes.
And what does that tell you?
Well, it tells you the two of them aren't identical in their velocities and their compositions. And so all the little variations in the placement and depth or height of those absorption and emission lines, they tell us something different about the story. So, for instance, we've all seen what happens when you turn on a blue light and a red light and you partially overlap the light and you see purple in the middle. You see the combination of the light from the two sources.
Right.
Well, this is exactly what happens when you have a planet passing in front of the star. You have the light that isn't going through the atmosphere, and you have the light that is going through the atmosphere superimposed together. And if you're able to say, okay, I know what this light from the star is, let me subtract that. That lets you see just what the planet and the planet alone is. And it's this secondary rainbow, which interestingly, because the star and the planet have different velocities, is actually going to be blue shifted or red shifted.
Right.
So the individual, let's say there's carbon dioxide in the atmosphere of that planet, we'll see all those little carbon dioxide lines shifted from any carbon dioxide, if it's a super cool star, in the star's light.
Wow. And so that way you may know, like if you see carbon dioxide, you may say, okay, well, we know there's carbon dioxide, but we don't know whether it's coming from the star or the planet. But it turns out you can tell just by how that light is shifted. So what are the instruments? What are the tools that astronomers use to study the atmospheres? Again, it's just blowing my mind that I'm even saying these words. What methods, what tools in terms of telescopes, what observatories is doing the heavy lifting in studying the atmospheres of these other planets?
Well, the old workhorse that did this for the longest time and is sadly no longer with us is Spitzer. The first mission to really be able to say this world has an atmosphere and we're looking at it was that telescope working in the infrared, where the light from planets is brightest, because planets are just warm little bodies. And so we emit the most light in infrared, and stars are often fainter in the infrared. So you're dealing with less starlight, more planet light, and Spitzer was kind of ideal for this. JWST, when and if it launches, is going to be even better. But
when it launches, not if.
It's 2020. You have to grant me the if in 2020.
Possibly, yeah. This is a year in flux. I'll give you that.
So right now we don't really have any big workhorses, which is very frustrating for the TESS mission, which was designed to find these transiting planets and send the data to JWST for follow-up. So we're having to get creative in what we do. And that creativity means working with the Very Large Telescope and other telescopes here on the planet to go as far into the infrared as our atmosphere is going to allow us to go, and use ground-based instruments. And one of the ones that's proving itself best is Express. Express really earned a name for itself with the Mascara 2 discovery. That's an actual planet name. I have no idea what that acronym is, where it started to be able to look at planetary atmospheres in detail to see what all is out there. And right now we're at this really cool stage where we're able to see hot Jupiters that clearly have lead in their atmosphere. We're able to find white dwarfs that have anomalous chemicals around them that point to gas giants getting shredded apart. Now, what we haven't found yet is that world that clearly has oxygen and other signs of life. But side by side with all the folks that are working and doing these atmospheric measurements are folks doing atmospheric models.
Wow. Yeah. So I guess that's the next step then is we're starting to see enough of these measurements of these atmospheres that they're starting to get some confirmation of the models, which they've been working on for a long time. And we've been seeing just some incredible models of exoplanets. So how do they think that exoplanet atmospheres would work? Because I guess the point is that you would be looking for things which we don't have in the solar system,
Well,
trying to figure them out.
at a certain point, a planet is a planet, and it's going to have an atmosphere that is suited to the chemical composition and temperature structure of the solar system it formed in.
Right.
So this means that we are looking at superheated gas giants. Kelt 9b comes to mind. This is a gas giant that is so close to its host star that its surface facing its star is the same temperature as some stars.
Yeah.
Now, it's getting roasted from the outside. It's not generating that heat from the inside. But when you're looking at a planet like that, you don't expect to see nice, happy, everyday hydrogen and helium because it's been ionized completely.
Yeah.
And this is where we start looking for things that have a few more electrons that they hold on to a little bit better. And this is where we're doing things like looking for sulfur in these atmospheres.
I know that there was one planet, it was a hot Jupiter, that we were seeing things like molten iron in the atmosphere, molten aluminum, places where it rains titanium. Imagine clouds, but the clouds are made of titanium. Like, it's that hot. It's so hot that every possible metal turns into a gas and forms clouds. Cloudy with a chance of titanium rain.
And this is showing our bias in what planets that we've found so far. Now, we don't actually know what the typical planetary, how often you have hot Jupiters versus how often you have little tiny worlds like Mercury that we're unable to detect at this point in time. Currently, because it is easiest to find massive planets really close to stars, most of the planets we have found are these massive planets very close to their stars. We're getting better. Today we had the announcement of a 2 Earth mass planet orbiting a regular star.
Yes.
So we have finally found a fat Earth, is what I'm going to call this.
Right. Yeah.
And it is beautiful in its earthiness, and it's 3,000 some odd light years away, so we're not getting there anytime soon. But the fact that we have found this sucker at 85% likelihood, there's still error bars.
Right. And of course, I mean, it's crazy to think. I mean, we found Earth-sized worlds. We found Earth-sized worlds orbiting in the habitable zone of their star. It's just that star is a red dwarf.
And these worlds are tidally locked, which gives them a different temperature profile.
So what would we be wanting to see? So, I mean, as that next round, I mean, for example, there's a new telescope coming out. It's probably going to be launching in 2028, the European Space Agency's Ariel telescope, the Atmospheric Remote Sensing Infrared Exoplanet Large Survey. And that is going to be a telescope designed to study the atmospheres of exoplanets. It is going to be able to study the atmosphere of like Earth-type worlds around other stars. What will astronomers be looking for?
Well, there are 2 teams that have put together atlases. We have a team from Berkeley, a team from Cornell, and they have been working to basically map out the distribution of different kinds of planetary atmospheres we can expect. The group at Cornell in particular have been trying to map out what you can expect from Earth-like planets at different stages in their evolution. So here they've done things like look at our own historical record, geologic record of our planet Earth, and said, okay, during the Cambrian period where we were having massive outgrowth of small forms of life, what did Earth's atmosphere look like? All right, so fine. What did it look like during pre-industrial civilization? What does it look like now? Looking at a myriad of different points in our planet's history where we had methanogens, where we had our normal now oxygen producing plants, and saying, okay, here is at different stages in a planet's evolution what you would expect its atmosphere to look like. There are also massive astrobiology collaborations that are looking to say, okay, if your life has this technology, look for this. If it has this technology, look for this. Pollution is a great way to find life.
I like that idea that if you look back at the history of the Earth, there are, what you said, there were 6 major moments or so.
Yes.
Each of which has a dramatic, like the time at the beginning when it was just being smashed by asteroids, a time when it was a carbon dioxide atmosphere similar to, say, Mars, and then a time when the oxygen started to take over, and you can see a very different signature in the atmosphere of planet Earth at each one of those times. And now you can just, as we are able to actually examine these other planets, you just map them over and go, okay, that is a desolate world that is being hammered by asteroids. That is a world that has cooled down but doesn't seem to have any life on it. And, well, what's this? Right? That's interesting. We're seeing a planet with oxygen in it. And it's really important work to start setting up these models now, so that when we know of the atmospheres of thousands of planets, we can make these, start matching them up.
And it's got to be so frustrating for some of these scientists that were working really hard to have their atlases come out coincident with when JWST would be going up. And we're expecting rapid fire return on investment as world after world was measured as they were found by TESS, and nope. So now we're in this wait and see game where it's just like, we know how to do this. We could be doing this. We have the publications on what to look for. We have tests. But at least we have VLT, the Very Large Telescope system of 4 many-meter telescopes and a bunch of 1-meter side dishes. And it's doing the best it can from here on the surface of our planet. And scientists are showing over and over that if you don't give them the toys they want, they're going to repurpose the toys they have to do things no one expected.
Right.
We are measuring iron rain.
Yes. Yeah, exactly. I mean, obviously there are, like I said, there's the aerial telescope that's going to be coming, and its job is going to be to do that. There's the HabEx telescope, which could be one of the next great observatories from NASA, which will do that at an even greater scale. And then there's the next round of the mega telescopes, the extremely large telescope, the 30-meter telescope, the Magellan telescope. So each one of these could be brought on board, of course, James Webb. So really, we're really going to shift that emphasis from let's see if we can find planets at all to let's study planets and see how similar they are to familiar planets.
And what I'm really looking forward to is, right now we're at this point where when we find an atmosphere, it's usually quite extreme. There's actually been cases with these tidally locked worlds where we have been able to measure the differences between the day and night side temperatures and atmospheric compositions, because as the small round world orbits in front of its host star, we're actually seeing more of the day side as it goes into the transit, and then more of the day side again when it comes out of transit. And that effectively shows us sunset plus nighttime, just nighttime, and then sunrise plus nighttime. And these minor variations allow us to do even more complex math, where we're now subtracting the star's light, subtracting the light from the nighttime side of the planet, and we're getting left with morning or evening to be able to do complex, essentially meteorology of extreme worlds. But right now, we're only at the extreme worlds case.
Right.
We're only able to do this with these worlds around red dwarfs, with these massive worlds snuggled up to any kind of star they feel like snuggling up to. We can't yet do this with that fat Earth we just found.
Right. I guess
we're getting there.
Yeah, we'll get there. Well, so and in terms of technique, like when you are trying to look at the planet in front of the sun, you're essentially backlighting the planet to be able to observe the atmosphere, you've got a very powerful light source. So
Yes.
if those planets are farther away from the sun and you are actually attempting to block the light from the sun, it becomes a much more challenging job of doing spectroscopy on that planet when you aren't observing
That
the star.
that's actually way less of a problem.
Oh, really? Okay.
Yeah, so the distance between the planet and the star doesn't matter at all as long as the planet lines up with the disk of the star. And that's actually the bigger problem. If you have a star with a little tiny planet close to it passing in front of it, it can have a whole lot of different orbits that still put it in front of that star. As you get further away, the number of orbits, the amount of shift you can have in how far up or down your orbit is that keeps you in front of that star, well, you're eventually going to fall off the disk in a
Right.
lot of cases. So it's much more rare to find these distant planets transiting perfectly in front of their stars. But if we see that transit, it's still just going to be sunlight through an atmosphere.
But I can imagine this future where these more powerful telescopes, like the Extremely Large Telescope or James Webb or Ariel, are just observing this planet directly. They're blocking the light from the star and they're just observing the planet no matter where it is on its orbit, whether it orbits above or below, whether it orbits us face on. I mean, each one of those kinds of observations will be fascinating. It's just we need to get really good at blocking the light from stars and really good at
And one of
observing faint planets.
and it's the faint planets that's going to be hard. The first thing we're going to be able to do is go that 3 pixels, those 3 pixels.
Right.
But taking all the light from those 3 pixels and then spreading it out into
Yes.
spectrum gives you essentially no detectable amount of light.
Right. Right.
And so
So if you've got
that's where it
one
gets tricky.
photon, it's really hard to turn that single photon into a spectroscopic diagram. You're just like, oh. But it's when
Exactly.
you do need a lot of light. And the way you get a lot of light on a thing that's very faint is you have a very powerful telescope and you gather light for a very long period of time. And
But these
so,
suckers are moving.
yeah, and on a moving target. And so
Right.
we're going to see these give up their secrets very slowly.
It's true.
Yeah.
It's true.
And
But they're going to give up those secrets. Those secrets will be ours.
I love it. I love your confidence. Good. Well, and I think, when do you think we will start to start, like, where we will know about the atmospheres of thousands of other planets? What's your gut tell you? Like, the
My
way we
gut
know
tells
of thousands of other planets, when will we know the atmospheric composition of thousands of other planets? We know probably like 10 right now, maybe 5, right?
I think we're doing slightly better than that
Yeah.
if you count the ones that we can say, oh, it has this one element we can detect,
Yeah.
but we can't tell you a whole lot more.
Yeah. Yeah.
So it's going to take a dedicated planet observer that has spectroscopic
Right. And that's the
capabilities.
Ariel. So that's 2028. So probably it's going to do 1,000 planets and do a large scale survey. So I guess starting in 2028.
Exactly. That's going to be our new Kepler just for
That
atmospheres.
sounds amazing. Pamela, do you have some names for us this week?
I do. As always, we are supported by the generous contributions of people like you. And I just discovered I logged into entirely the wrong account. So you're going to need to pardon me for one moment while I log into the correct account. Allie, more editing. I am so sorry, Allie. I want to thank people. I just want to thank the right people. Fraser and I both have personal Patreon accounts that you can support to support our own work. I am patreon.com/starstrider. Fraser, your universe today.
Yeah, Universe Today.
And then this show is supported. We pay our web content producer, Beth Johnson, our video engineer, Allie Pelfrey, and our audio engineer, Richard Drum, through Patreon and
/Astronomy Cast.
yes,
Yeah.
/Astronomy Cast. So the people I would like to thank today, and again, we could not do what we do without the generous contributions of these people. And we're even hoping to start offering benefits, medical benefits soon to our part-time employees, because now more than ever, everyone deserves health care. So your contributions, if you're already donating, thank you. If you're on the fence, now is the time to get off the fence and give, and be part of providing medical benefits. And so this month we would like to thank Les Howard, Adam Annis Brown, Emily Patterson, Infinitesimal Ripple in Space Time, Ed Loves Science, Gordon Dewey, Bill Hamilton, Sinai, Joshua Pearson, Frank Tippin, Alexis, Richard Riviera, Thomas Sepstrup, Stephen Shewater, Sylvan Vestby, Jeff Collins, Merrick Vidarni, Arctic Fox, Brian P. Cox, Nate Detweiler, Matt Rucker, Brian Gregory, Ron Thorson, Dave Lackey, Kevin Nitka, Philip Walker, Chris Scheifhofer, and GeForce 184. Thank you all so very much for everything that you do that allows us to do what we do.
Thank you so much, everybody. And Pamela, we'll see you next week.
See you next week. And now we save. I have a dog just off camera who's been like licking
on camera.
Me for...
The dog is
she
not.
is?
Yeah, the dog is not off camera. That is an on-camera dog.
Okay.
It's fine.
Oh, just the corner of her is on camera.
Yeah, it's not like a harsh rebuke. It's a celebration of an on-camera dog.
Yes, I know. You are getting closer and closer, and I don't know why. Now you're gonna run away. All right. Sucks, man. Sucks. Your dog is disturbingly cute. Like, oh my goodness, all the snoot poop with your dog.
She's a very cute dog. Yeah. She. It's so funny. We're teaching her how to dog. So because we really feel like she was found on the streets of Oakland and then was rescued, and she had puppies before and then went into a series of homes, and so we suspect that she was like in a puppy mill and didn't really get very good of a life early on.
Yeah.
And so there are these basic things that dogs do that she doesn't do, like she doesn't play with toys. Right? Just no. She had before. She had no concept of toys. You would throw a ball and she would just be like, I don't know what you just did, human. I can't eat this, so why are you wasting my time? And she's now gotten to the point where you throw a ball and she's like, oh, my job as the dog is to go and catch this and bring it back to you? All right. Yes. It's not because she loves it. It's just because she knows that this is what she's supposed to do. So it's very different than a dog that just loves to play with a ball and will play with the ball, over and over and over again. You throw a stick and she is not interested whatsoever. But over time she's gotten better and better and better at this. And now she's got toys that you give her that she'll run by and pick up the toy and give it a big shake and throw it in the air and then keep going. You're like, right on. But she doesn't even know how to say catch food. So you take food, like really tasty snacks, and you throw them her way, and they just bounce off her face. She just can't. There's no timing. There's nobody has ever said, here, a way you can get this food into your face quicker is to just open your mouth when it arrives and grab it.
I've had to teach Malachi, who we adopted last year, how to catch food. Yeah. And there has been a whole lot of Cheerios involved.
Yeah. And so we're getting a little better. Like she'll start to shake her head and move it in the right direction or open it a little later. So she's starting to learn to do this, but it is very funny to just see that she's not. There's just these basic dog skills that she does not have, and it just leads you. I mean, she's such a wonderful dog, and is so deeply bonded with us at this point. But yeah, no, it's quite amazing. Holly Meyer was saying, wish she could support. But can't right now. And I just want to tell everybody,
totally get that. Yeah.
Understand, right? That the supporting us is completely voluntary. If we had no support, we would still do this show. It would suck more.
Yeah, there'd be
right?
there'd be minor editing by me, and it would be terrible.
Yeah, we would just rip the audio from the live show, and we would, throw it. Maybe it wouldn't even exist as a podcast. You just pull it from YouTube, whatever, right? So I think that no matter what, we would still do this work. But the thing that's amazing, the thing that gives us incredible inspiration, is to come and show up and know that people like what we do and they're supporting the work, and we are able to hire other people to do stuff that they enjoy. I mean,
exactly.
Same thing with Universe Today. I mean, we have the patrons, and that lets me hire people. And especially now, like, I've been able to give more people work than ever. Mostly because I've cut all the rest of my expenses to the bone, but to be able to try and keep as many people employed as I can. And literally I take the Patreon money and I turn it around and I just send it to other people who can then do work. And the more support we get, the more space news. Like, I promise you, I will spend all the money on more space news, on more journalists writing more work, on more video editing, all of that, right? And it's just a balancing act. As much money as I get in, at the same time, I need to balance the fact that I've been doing this job for 20 years. I'm not going to run out of money, right? I'm not going to drive myself out of business. So I have to play that really careful balancing act. However much money comes in, that's the amount I can spend on space news, on hiring people. And so, but at the same, and it's super gratifying to be able to be supported by the fans, and to not have to be supported by purely by advertisers, which are a fickle customer, and they don't really care about what it is that you're creating. The advertisers they are there because they want the eyeballs. They want access to your audience.
Yeah.
But the most beautiful thing is when we get to be supported directly by the fans. What do you want to know about? We will create content. It is closing the loop. And the fact that, I mean, at this point, I think I've been on Patreon for 6 years. Like, it's been a long time, and it's slowly growing over time. Mm-hmm. And it is this safety net that it's just never existed in the history of what we do. And if for me, for Universe Today, if Patreon dipped down to zero, if advertising dipped down, then I wouldn't do this job. Like, I couldn't afford to do this. I would be working, as I've mentioned many times in the past, right? Like, my experience and training is to be a executive in a technology company. So you wouldn't have Universe Today. You would have Fraser making Microsoft Word better. So.
And we prefer this, Fraser.
Yeah, me too.
Honest.
I much prefer that I take all of this experience and training and knowledge and education and focus on teaching people about space and astronomy, as opposed to making a better spell checker.
And one of the things that Fraser and I have both had the ability to do is give people who aren't in a position to take full-time work for various reasons the opportunity to have a career in science communications, where we both have people on staff who are either taking care of kids, have health issues, have whatever it is, they're still in university, that prevents them from having a full-time job, but they need a job.
Mm-hmm.
And it's so much better to do this than whatever other part-time gigs are out there. Because let's face it, most jobs want you full-time or not at all.
Yeah.
And so right now we're just at the point of, okay, it would also be good if we had health and vision.
Yeah. Or move, I mean, I fortunately, I actually do a lot of Canadians on the payroll.
Yeah.
So I don't really worry about it.
You don't have these issues.
No, I know. So I'm happy to pay freelance rates to all of my writers. Arjun is asking, how do you distribute stories to your journalists? Do you just go by specialty? That's a great question. So we built an app. Actually, Chad helped me because Chad, in addition to being our video editor, is also the programmer for Universe Today. And so we actually have a story assignment system. And so I put in all of the stories in that system that are open for anyone to work on for Universe Today. And then the writers look through the list and they just grab stories that they think are interesting to them and then they write them. So they choose, but they also have specialties. And so if I have I know that, say, Dave Dickinson is our amateur astronomy writer, and Nancy Atkinson is really good at human spaceflight stories. And so sometimes I'll get, say, Brian Koberlein or Paul Sutter to do astrophysics cosmology stories. So I will tend to assign them to different people based on their specialties, and I think they're the best person tasked to be able to handle it. But really anybody can handle the stories are all sort of free for alls. They can grab the stories they want and then work on them.
And we use Trello to do pretty much the exact same thing, but Trello, because I'm lazier. And
it costs us some money to build.
Well, so Trello is free at a small enough board. And there's a great integration that allows you to send things from your email to Trello or to send a web page to Trello. And so I'll go through, or Beth Johnson will go through all the press releases that have come out and send the ones that we know we're going to do stories on or potentially do stories on to Trello. If it's an embargoed story, then anyone on the team is free to write about it. If it's not embargoed, then I'm probably the only one that can write fast enough to get it out for the daily space.
Right.
And then Annie, who does our Rocket Wednesdays, she just flat out assigns stories. So like this week, I was assigned SpaceX. Right. That was mine.
Right.
So same principle.
Yeah.
We're just using Trello.
Yeah. And it's just because the system, if anyone follows me on Twitter, you'll see the stories that I'm considering, and then you're actually seeing a list of the stories that we're going to be potentially publishing on Universe Today. And then our system pulls those tweets that I send automatically in and pulls the image, pulls the title, pulls the link to the original source, and then and then pulls in all of the additional data so that it's very easy for the writer to kind of jump on and start working on the project. So
now, are you still using? I don't remember if you were using Zapier or if this.
We use Zapier for this. So every couple of minutes, Zapier will read through. It's like it's like it allows you to connect different applications together. And so our internal story assignment system checks every couple of minutes and sucks in new stories and puts them into this system conveyor belt. Right?
Accurate.
Yeah. It's like, there's probably 15 maybe new stories that we're considering every day. And then the writers pluck out.
Yeah.
Usually we publish maybe 5-6 stories a day on Universe Today. So about a third of the stories just sort of go over the other side of the conveyor belt and never actually get covered on Universe Today. And it all depends.
So this is unrelated, but I have to ask. So we have started referring to Perseverance as a needy little robot.
Why?
The Perseverance mission team, whomever, we have been getting anywhere from 3 to 8 press releases per week from Perseverance.
It got wheels.
Like, it's chill. Yeah. Just chill, little robot. We know you're there. It's okay.
Yeah, it got wheels. It got cameras. It's got a little helicopter on it. Yeah.
It's demanding so much attention. It is literally the neediest little space mission we've ever seen.
Don't we know a beloved space journalist who took on a job at the Jet Propulsion Laboratory in their media outreach group? Ian O'Neill, Dr. Ian O'Neill.
Yes, he's a great human.
Yeah, and so I know that Ian is working there. I don't see his name on those press.
I'm not going to blame him for Perseverance. This is not his doing.
Nope. But now we're going to get into how the sausage gets made here. Something that I've told various space agencies and universities and stuff for the longest time is you don't need us, the media, at all. All you need to do is so it is not them sending you a press release. It is them writing a news article about their their progress in building the rover. Don't see it as them begging you to republish their news. They're keeping the public up to date on what's happening with NASA. And so as soon as I guess everyone out there realizes that they don't need us as journalists to I guess help them get publicity, then we're out of a job. But fortunately, it's a lesson that I don't think they're ever going to learn. But it is a funny thing that people will send me a press release, but they haven't even put that press release on their own website. I'm just like, just start there. Like, just if you have news, like put your news on the website and people can go read it. You don't need,
or don't hide it. The number of times that we've gotten we get press releases that link to universities' homepages.
Yeah.
And it's just like, this is not useful.
Yeah, you've made it. You could not have made it harder for us to do our job to promote your work. Like,
and always have a shiny picture.
Yes. There was always have a picture.
Kepler 160 today. No good picture. I actually used my own artwork to illustrate a story.
That is awesome. Yeah. Like, have a picture, have a place on the internet that you can link to it. Do those two things and you're ahead of 50%. Don't use some weird, complicated WebP image system that we can't use for our stories that you're doing. Like, just don't make our lives more difficult.
The people who post pictures that we can't get off their website without getting into the inspect and search and URL hack.
Or with really low resolution. Like, just like, do you or do you not want us to write news about your research?
The most annoying thing you could do as a press officer is the following. Send me a press release that links to your institutional homepage. And then when I finally do find the press release on your site, have a low-res picture of the scientist and nothing else.
Right. Yeah.
It is less annoying to have no image at all.
Yes, we will just come up with something. Yeah. Yeah, that is the anyway. So if you are taking notes on how to be a better press officer, allow us to help you out. Yeah, Nibbler is saying being able to right-click save is a basic human right. Totally agree. Like, just don't put things on your website that make it difficult for us to build our story. Make it easier, please.
Flickr is the one place that I'm down with not being able to always right click, because it means there's more pretty pictures.
Yeah. Yep. Yeah. So anyway, so there you go. We just did a Arjona saying, don't they have departments that handle communication with the public? Yeah, they have a public relations department. They literally
that doesn't mean they're good.
Any public relations department in any university has more budget than either Universe Today or CosmoQuest, I suspect.
It's true.
Yeah.
All it takes is having 4 full-time people, and they've topped my budget.
Yeah. Yeah, exactly. Yeah, no, if you hit 4 full-time people, you are spending more money than Universe Today can.
Yeah.
So that is
perspective.
It can't be hard.
Yeah.
Oh, I love it. Anyway, if anyone had any questions, okay, we got like 5 minutes. Nibbler asks, is it a problem for precision when the star and planetary atmosphere have similar elements and thus absorption lines?
It depends on the angle of inclination of the system.
I mean, you talked about this idea that you can tell from the Doppler shift.
Yeah. So that's where the angle of inclination on the sky matters.
Yeah.
The closer you are to edge on, the more the difference between the to and fro of the two worlds kicks in.
Yeah.
Although when the planet is perfectly superimposed on the star, you're out of luck.
Right.
But if the system is more tilted, then you'll get less and less difference in velocity, because the velocity isn't in and out of the sky, it's in the direction of the sky.
Right. Question from Bim Jim. When will it be possible to have the star blocker be another spacecraft? So they're talking about the star
chronograph.
shape.
for W first is the first one we have any hope of.
I don't think there's going to be one for W first.
Well, they're still talking about it.
But I think Habex is the one that's going to have the star shade.
Okay. So the issue that we're dealing with is, and W first has recently been named the Nancy Grace Roman telescope after the woman who was the first chief astrophysicist at NASA and really drove NASA to have a strong science component. Unfortunately, W first is once again entirely on the chopping block of the president's budget, along with the Sophia Airborne Observatory. Right. So unless Congress has line item money for those two missions, they're dead.
I like their odds. They've tried to kill them every year, and they just keep coming back. So I'm not worried.
Yeah, it's 2020. I remain worried about everything.
Right.
Everything.
And so you should be.
I had a chunk of my ceiling fall last time I was on Weekly Space Hangout Crew.
That's awesome. Arjone asks, could you tell anything from when a planet is about to go behind the star? It should be fully illuminated then. So I guess like when you think about how Venus gets really bright just as it's getting closer and closer to the star, does that help?
No, because we lose the planet in the glow of the star at that point.
Right. So
it's hard to do that observation with Venus.
So
it's harder to do with distant worlds.
Did you see all of the pictures that were out on Twitter this week of all the people that are capturing Venus as it got within just a couple of degrees of the sun? Just amazing work. Yeah.
No, my Twitter is completely dominated by the fact that I live in a nation that's about to undergo civil unrest.
Right.
Is undergoing civil unrest?
Yeah, I would say you're undergoing civil unrest. Very civil unrest so far.
I don't know. All the people who are being gassed wouldn't agree with you. I will remind everyone we bombed Syria for doing to its people what we're currently doing to our people.
Oh yeah, no. I just think that it could be so much worse. We have examples
Guns here.
It's the year. The year isn't even half over yet, so we have time to potentially watch it get a lot worse. But I really hope it doesn't.
Murder hornets. There are murder hornets.
We have them on Vancouver. We had them on Vancouver Island. That's not only do we have murder hornets on Vancouver Island, but we also now have grizzly bears. So
was that paw print you saw potentially?
No, that was a black bear for sure. But I was talking to a friend, and he was driving a little farther north on the island, and they're finding that grizzly bears are swimming across from the mainland onto Vancouver Island, and they're getting pushed out of essentially they're getting, they're younger males that are getting pushed out of the territory on the mainland on the British Columbia coast.
Does this mean they're finally returning in large enough numbers, or that humans are encroaching too much?
I would say that you're getting more of them. Like you're getting more bears, and so they're just getting too tightly populated, and so they're having to escape. But the problem is there's not a lot of resources to support a giant grizzly bear here.
Yeah.
And so
you don't have enough deer.
Yeah, and there aren't a lot of females for them, and so they're swimming back to go mate. So I think this is now a thing they know how to do. They've gone aquatic. They're sort of like marine grizzly bears, which is kind of a terrifying thought. It's like a whale, but a dolphin, a very furry dolphin. But they're huge. They're so big. I mean, just like a full adult grizzly bear is just like you're seeing a furry dinosaur. They're monsters, and they are terrifying to see. And so black bears, they're nothing. I
love black bears.
Just, well, I mean, they get to 1,000 pounds, so they like a great big dog, a big fat black furry dog. But a grizzly bear is like a mountain that's moving around. They're really terrifying. So anyway,
and they're less interested in honey and more interested in everything.
They like honey. They fish. They love to eat. They love to eat salmon, and they love to eat your garbage. So, but so we're gonna have the grizzly bears, coming down the island, the murder hornets making their way up the island, and here's me right in the middle. So I'll keep you all posted.
You're becoming a country song.
I know. All right. I think it's time to wrap things up. Thank you, everyone, for joining us on this very bizarre episode of Astronomy Cast. We couldn't do this without you. Thanks, everyone, on YouTube and on Twitch. Thanks to all the moderators, all the fans, all the patrons. Thank you, Pamela, for joining me again. And you've got, I believe, 3 more episodes?
I think so.
All right.
I think so, yeah.
New Virtual Star Party Sunday night. Join us. We'll see you all later.
Bye-bye, everyone.